Well, hello everyone. Welcome to the Peanut Labs monthly webinar. I'm really glad you could make the time to join me today. My name is Annie Pettit, and I am the Chief Research Officer at Peanut Labs, a company that specializes in full-serve and self-serve research sample. Today's webinar will be recorded, and it will be available with all of our other webinars on the Peanut Labs website. And you can find those on the resources page of our site. I'm going to talk for about 25 minutes, and I'll save a few minutes at the end for questions. So do feel free to type any questions you might have along the way into the box on the side of your screen. So big data, that is today's topic. It really does seem to be the topic du jour, and you can't go anywhere online without hearing something about big data. For us as market researchers, it makes huge sense. Big data is of utmost importance to the work we do in trying to understand consumers and consumer behavior. Big data is, after all, a giant listing of consumer behavior ready and waiting at our fingertips. And we all know very well that past behavior really is the best predictor of future behavior. Let me start by taking a quick look at exactly what big data is from a marketing researcher's perspective. Now, first, of course, big data is all about volume. And if you think about a market research panel consisting of millions of panelists taking millions of surveys and earning millions of incentives, it's definitely a big data set. And the same can be said for any marketing researcher who works directly with transactional or shopper loyalty data. They see millions of shoppers making trillions of purchases at thousands of stores. Another aspect of big data is variety. And if you look at all the data we deal with as marketing researcher, it definitely qualifies. In a panel data set, we've got dates, times, latitude, longitude, email addresses, sometimes user photos, audio, and video. We've got a full range of data types. The third main aspect of big data is velocity. So we've got survey completes coming in every nanosecond, and we're recording who clicked or screened or completed or failed due to data quality issues. So big data is really living data. So now that we've seen the types of big data that some marketing researchers work with on a daily basis, let's have a look at a few of the myths floating around there, the myths that keep more of us from diving headfirst into big data ourselves. Now first, it sometimes seems like big data is new. We only heard about it this year or last year. It's a strange concept, and given that many of us have only a history of working with surveys or qualitative research, handling data sets with more than a few thousand records does seem kind of crazy. If you look at the picture here, this is a brand new computer that was built this year, and it can take on the biggest jobs that no other computer is capable of handling. And the quote you see here describes the amazing capabilities of this computer. So we finally have a computer that can truly handle big data. But let's just wait a minute. Let's jump back to 1985. That's when this amazing computer was built. And this computer, let's read the quote, allows users to solve problems that cannot be solved with any other computer. So isn't that big data? Do you think big data was only invented this year? Of course not. Big data has always been around. There's always been a situation where someone had far more data than they were able to handle. So what is big data really? Well, decades ago, big data was megabytes. Then over time, big data became gigabytes and terabytes, and now it's petabytes. So it seems to me that big data is simply having more data than the software you own can handle. I can even take a more personal look at my own use of big data, and it's definitely not new either. So more than 10 years ago, I was using a transactional database to identify people who would be more or less likely to purchase an item at a store. I used drugstore data to run shopping basket analyses. After that, I was analyzing millions of records in a research panel database to identify which panelists were more and less likely to complete surveys, as well as more and less likely to provide good quality data. Then I analyzed millions of social media records to identify sentiment towards different brands. And now, once again, I'm analyzing millions of research panel records to weed out poor responders and become more intelligent about how we use our panel. Not one of these times did it ever occur to me to call this work big data. Even though in every case I was dealing with millions of records and databases that never stopped expanding in size and that contained all forms of data types from geography to clicks and images and more. So it really makes me wonder how many of us have been using big data all along, but we just didn't use that word. We just called it marketing research. So really, I don't think big data is new at all. We just have a new label for it. On to the next myth. Volume trumps knowledge. Well, the fun thing with this myth is that we get to correlate anything with anything. If I look at my panel data, it is technically possible for me to correlate dates with geography or usernames with zip codes. I can correlate anything that uses letters or numbers with any other variable that uses letters or numbers. And I can guarantee that some of those correlations will be statistically significant. You see, when you're dealing with millions of records, practically everything is statistically significant. Any moron can click on a button that says, correlate this. That doesn't make it important or meaningful. And as you see here, we've got an excellent correlation between space launches and sociology doctorates awarded. It doesn't matter what the sample size is. This is just a spurious correlation. Here's another great example, or a few examples. We've got 4 correlations here. So for instance, people who are more likely to wear a rounded neck than a V-neck sweater are more likely to not sing or hum along to music. Or people who are probably addicted to caffeine are more likely to have dated a coworker. I can make some sense of that one. But these are 4 more examples where they're just spurious correlations. The data just randomly will correlate anything. Now those examples were fun and games, but here's a real example. So I took a sample of data from the data I use every day, and I decided to calculate the average length of time it takes people to complete a survey. So the easiest thing to do is simply find the variable that says survey length and then average it. Anyone can figure that out, just find the variable and average it. So in this case, the average time it took to complete a survey was 4.7 minutes. Easy peasy. But those of us in the business know just how wrong that sounds. It sounds horribly wrong. And those of us in my business know even more about how wrong that is. So at PETA Labs, our panelists choose from a variety of tasks, not just surveys. So the very first thing I needed to do was exclude any task that wasn't a survey task. So right away, this increased the survey length from 4.7 minutes to 5.1 minutes. It's still not making a whole lot of sense to me from what I know about surveys. What I know says we really do need to look at people who finish surveys. We can't be including partials. So when partials are taken out, the average survey length jumps to 15 minutes. And then after accounting for only US completes and only completes in the last 6 months and excluding tester completes, what I end up with is an average survey length of about 16.5 minutes. Now, could someone who doesn't know anything about the survey world know all about these intricacies? Of course not. You need to have domain knowledge to do this, and more data does not mean more domain knowledge. So without understanding what happens behind the scene, without the domain knowledge, there is no way that a data scientist could account for any increases or decreases or changes in average survey lengths. They wouldn't know that changing survey invitations or changing the panelist sources or changing the incentive strategy would change average survey lengths. Those of us in the field, we understand those kinds of things intuitively. So if volume of data can't beat domain knowledge, can the speed of big data make it the winner? And I'm sure you've already guessed that the answer is no. So for instance, here I have charted survey completion times by the second. Fascinating. We can see the exact completion rate 60 times per minute, times 60 times per hour, times 24 hours per day. But is that useful? Absolutely not. It helps me nothing to calculate these rates so quickly. What I really need to know is how do they differ from yesterday, from last week, from the same time last year? How do they differ for men and women, or older people, or uneducated people? Did the rate change for just one group of people? And is that change related to something else happening at the same time? So you see, we can pull data instantly. That's fine. We can see the last second of data. But unless you apply your brains to the data and really think about what you're doing and why things are happening, fast data is simply data. It's not actionable. You have to use your brains, and brains take time. Speed is not everything. So here's another big myth. Many people believe that big data is clean because it comes direct from the source without any manipulation. But take a look at this table from one of the data sets that I use. This table has over 75 million records and over 1,000 variables. And there are over 50 million missing data points. So which data points are missing on purpose? Which ones are missing because someone forgot to type in a job number or a job name or a project manager name? Which ones are missing because this file didn't sync up properly with another file? It's impossible to say unless you dive in and start figuring each one out one by one. In this case, those of us who know the survey domain can see what is and isn't clean. In this case, we're looking at survey lengths. Most of these data points show reasonable survey lengths of around 20 minutes. Still longer than I'd like, but it's okay. And I'm sure every one of you is staring at that one number thinking the exact same thing. That isn't right. That's not how long it took them to answer the survey. It didn't take them 8,000 minutes or 143 hours or 6 days to answer that survey. That person just decided to stop answering the survey one day and finish answering another day. So this data point is misleading. So anytime you use a data set, you have to carefully seek out and address anomalies. You can't just leave them in because, there's probably not very many of them. That's just bad data practice. Even big data has pieces of bad data. Now, one of the great things about working with big data is that you feel like you're working with all the data. And the main point of that sentence is that you feel like you're working with all the data. And of course, you're never working with all the data. The second you download data, you are missing data. If you downloaded your data yesterday or last week or last month, you could be missing millions or trillions of records. And that's not the population. So think about this. In my case, the IT team doesn't let me access all the data sets. And that's for good reason. Some of those data sets are highly confidential and I shouldn't see them, nor do I need to see them. In other cases, I simply don't have the passwords to access the data. And in still more cases, the rest of the data is in my competitors' hands. And there's no way they're going to share their data with me. So it's really idealistic to think you're working with the population. You're dreaming if you think you are. One of the problems that goes along with thinking that big data is the population of data is that once you have big data, you don't have to think about science. You don't have to think about whether your data is representative or if you can generalize from the results because you've got all the data. Well, this is completely false. We've already seen that big data is in the population. And because of this, we have to conduct our analyses knowing that we are missing some of the data, knowing that some of the data is miscoded or misplaced. We have to remember the basic training we received as researchers in terms of understanding how errors like type 1 or type 2 errors come into play. We really need to understand the concept not of total survey error, but of total research error. Now this myth is quite widespread as many people think that big data is something that the IT department worries about. Well, it's true. In many cases, the IT department created these data sets for their own purposes. And they have been the only ones to use the data for decades. But more and more, researchers are realizing just how important it is for them to access the data. The interesting thing is that the way we feel comfortable accessing the data is pretty much how data scientists access the data. Now, many of you might recognize this little bit of code as SPSS. Well, SPSS does happen to be one of the top 10 most popular software tools used to analyze big data. Now, here's another tool you might recognize. Some of you might not know SAS, but it too is a very popular tool among market researchers. And again, it is a popular tool among data scientists. And lastly, have a look at this bit of code. Even fewer of us know SQL, but this too is a common tool for data scientists. And what you will notice about these three tools is how similar they really are. The basic syntax is familiar and they're all quite logical. What it means is that if you've learned one, you can probably easily learn another one. So in my case, I picked up SQL on the job and with the help of a SQL for Dummies book. So yes, I'm a dummy. After just a couple months of working with the data set with the Dummies book, I was able to do pretty much everything that I needed to do for my work. No, I am not a SQL programmer, but I could do the things that I needed to do. So Gregory Pietsky did a survey among data scientists, and while the methodology would not pass any rigorous testing, they know that, he knows that, it's good enough to get a better understanding of the software that we should know and be learning. So immediately you can see that among the top 10 programs are 3 that many of us already know. And I know that some people are learning R, so that brings us up to 4 programs that marketing researchers already know. So once again, we have to ask, is data science for the IT department or is it for the marketing researcher? Nowadays, the word unicorn gets thrown around a lot as someone who has unique skills that are difficult to find. But if you think about it, especially in our industry, data scientists aren't necessarily unicorns. We know the math and the science. We know the software. We know the subject matter inside and out. We know consumers. So you could call us unicorns, but really we are so common you might as well call us data squirrels for all the data we've squirreled away. All right, so it seems like being able to do this kind of work must be expensive, but let's take a couple minutes to think about it. It doesn't have to be expensive. Anyone who works at a company that does any sort of data collection over the internet or collects data from shoppers has a giant data set already. They don't need to buy servers. They already have servers. They're already using servers. So in other words, it's really not going to cost you any more money to collect and store the data. That part is already happening. Another cost we have to consider is, of course, all the software you need. I'm pretty sure everyone has Excel on their computer, so you're covered there. And if you're not a PC person, you probably have a Mac version of spreadsheet software, so you're probably covered as well. What you might want is R or SQL or Python or any of these pieces of software. Take a wild guess at how much they cost. And the answer is nothing. These are free. These are all open source software programs for free. Download and go. So the price of software is also not going to hold you back. The last cost to consider is people. What you see here are costs from a salary survey. And if you look at the salaries of all the people on your team, a data scientist really isn't all that different. If you have all of these people, you can certainly afford to hire a data scientist, and you definitely should. The insights they can pull from your own data will astound you. It could be worth every single penny. All right, the final myth I'd like to tackle is that big data is better. And if you're a data scientist at heart, it will certainly seem like big data is better. But if you're a survey researcher, then surveys will seem better. And if you're a focus group researcher, then focus groups will seem better. It is all in the eye of the beholder. What we need to realize is that every research objective is uniquely suited to a specific research method. You cannot understand emotions and attitudes and beliefs with big data. You can understand what products get purchased together, which products get purchased on sale or at full price, what time of day different products are purchased. You always need to suit the task at hand to the right methodology, and it's definitely not always big data. Okay, we've plowed through a number of myths about big data, and we've seen just how suited marketing researchers are to working with it. Let me close by explaining exactly what big data truly is. First of all, it is fast. And don't think of fast in terms of the speed that the data arrives in the data set. Think of fast in terms of the fact that the data is already in a data set. You don't need to field it, and the sample sizes are already great. Second, it is actionable data. It's already been precisely defined. It's perfectly measurable. And we all know that you cannot act on something unless you can measure it. Third, it is highly relevant. This data is perfect in the sense that it's about your products and your clients and your key metrics. There is no more relevant data than this. You're making a huge mistake if you don't take full advantage of your data. And fourth, well, big data is not scary. Sorry, had you on the wrong slide there. That's okay. So you probably already spend the time to learn new software before. You had to learn all the programs that you're already using. You already know the research methods, so that's not a problem. And you're already comfortable with the domain. It really doesn't get much better than this. You might not have realized before, but maybe you are already a data scientist. All right, so before I close, there are a few minutes left if anyone wants to ask a question. So I'm going to give you a chance to write out any questions you might have in that question box. And let me just poke through and see if I can answer any of them at this point. Okay, I've got one question right now. Stephen, how do you get anything actionable out of big data? Definitely a good question. I've been asked that before. Um, the trick with big data, I think it's to treat it like any other data set you're getting ready to analyze. Don't treat it like a fishing expedition. It is fun to fish for a little while, but then at some point you just have to break down and do the work. So you need to have a purposeful hunt for a very specific answer. Prepare 2 or 3 very specific research objectives. Maybe, so if I think about my data, do men have longer survey completion times than women? Which website source gives panelists who ultimately provide low quality data and who subsequently have to be dropped from the panel? So those are 2 solid, actionable, measurable research objectives. And if you have these research objectives ahead of time, then the analysis falls into place. If you're just randomly wandering around the data, it's fun, but at some point you really need to stop and then just focus on a specific problem. That's how you're going to get something actionable in the end. All right, you have a peek here. Let's see any other questions, just some comments. So I think what I will do is close off at this point. So thank you very much, everyone, for making the time to join me today. Do feel free to chat with me on LinkedIn or Twitter or Facebook, or even by a good old-fashioned email. As I mentioned before, this will be recorded and placed on our website for you to review later if you wish. With that, may your data be full of clean and absolutely no errors at all. Bye, everyone.